welcome back everyone. I'm the host for this section, which is you guys can call me Sun Yang. I'm currently studying in Ta UC as a student right now. Alright. This sections, the speaking sections. Let's welcome Ugendra from Ombre, which is doing as machine learning engineer right now, and give you a talk about the mathematics and machine learning. Without wasting any time, I'll pass the stage to Ugendra.
Thank you, Sun Yang. Well,
Alright.
hello everyone. Good morning, and welcome to my talk titled "of Mathematics and Machine Learning." I'm your speaker, Ugenteraan, and if you have any questions, just post it at the side, and at the end, I will try to answer every question of them. Hope you enjoyed the talk. So, the first thing is, let me introduce about myself. I'm currently pursuing my master's degree in machine learning at Multimedia University, Cyberjaya. And while I'm doing my master's, I'm also working as a machine learning engineer at Ombre for the past 3 years. Joined at August 2017. So yeah, both are full time. Machine learning engineer is a part-time work currently, and some of the machine learning projects that I've done is lane detection for self-driving car. It was a prototype of self-driving car, and I'm the one that did the computer vision part for it. And object detection and recognition for the PPE, which means personal protective equipment like helmet, vest, gloves, and so on. It's among the construction workers. And a simple facial recognition software for a hobby. So if you want more projects that I've built, it's in my GitHub, and you can see at the link there. So it's always free for you to use. So before we move on to any of those boring mathematical stuff, let me just shortly introduce you something about Pringles. Yeah. So what's so special about this Pringles, right? Have you ever wondered why the shape of the Pringles is the way it is? Well, it's actually modeled after something called hyperbolic paraboloids. So what this means is that, okay, let me just introduce a simple history about it first. So the Pringles became famous right after the World War II. But then when it was packaged and packed and given to the users, the consumers, there were a lot of broken chips in the packages, because as you transport them through using lorries and stuff. So there were a lot of customer complaints saying that after they buy the bags and then inside the bag, the Pringles are all broken. So the company hired a chemist called Frederick J. Bau to fix this problem. So Frederick J. Bau is also very good at mathematics. So he spent 2 years to come up with a solution. So his solution is to use this hyperbolic paraboloid. It's a geometric shape to be used at the design of this chip. So it's aerodynamic enough to make the chip to not break when you stack on top of each other, and also when you transport them. So that's why it's so well kept inside the bags, inside the packages until now. And also the bonus is that it fits perfectly inside our mouth, and yeah, it's easy to transport now. So isn't that really cool? So you can say that mathematics is being used even at those very fundamental level, at even at our chips. So I don't know if that convinces you to the importance of maths or not, but it does to me at least. So now let's try to move on to something more a bit serious. So as you all know, the modern computer science that we use now, computers actually existed way long before that, but they probably don't fall into the category of computers for you. It's very simple machines back then. So the first modern computer was actually pioneered by someone called Alan Turing. So he was the pioneer of computer science in around 1950s, 1940s, around that era of time. So not only that, he also laid the groundwork for the theory of the modern computing and also artificial intelligence. So he is a pretty famous guy that you should know about. So he was working with the Enigma during the World War II, during the Cold War and World War II. So for fun, for your amusement, you can check out the Turing test and Turing machine. But basically, just a little bit about it. Turing test is a test that would uh, that is used to verify whether if an artificial intelligence passed the test to be indistinguishable to be human or not. So you can check out more by just googling about it. If you want more information about his life, his works, the struggles that he faced during his lifetime, you can check out a movie called The Imitation Game. It came out on 2014, starred by Benedict Cumberbatch. Not sure if you guys know him. It's a great movie, so you should watch it. And to make the cherry on top, he was actually a mathematician. So he started out as a cryptography mathematic. Uh, his mathematics field was in cryptography, where you can decode and encode and decode informations and send them over encrypted channels and stuff like that. So he needed a machine to perform the encryption and decryption faster. That's the entire story about how he found the modern computers. So now I think you should know at least a little bit more about how important maths is to computer science. All right. So now let's move on to some of the fun stuff in mathematics, right? So I'm aware that most of you guys here are Form 3 to Form 5 student. So I'm pretty sure that you must have read about functions at least once, especially in Form 4, additional mathematics, if I'm not mistaken. You should be introduced to it in Form 2. So you remember all those graphs of f of x, g of x, all those squiggly stuff, and we have to calculate the substitution, the composite functions, inverse functions, kind of boring stuff, right? We don't even know why we're doing it, but yet we just do it for the exams, right? So I promise you, this has to do something with machine learning. I will tell you in a bit about it. But before that, let me just tell you something about mathematics in general itself. So you see, maths and science always go hand in hand, right? As you all probably know. But unlike science, math is different. So one of the aspect that is different from is all those concepts. So you see, science, when you do experiments and you conduct those, when you have an hypothesis, you conduct the experiments and then you come up with the result and so on. What you're actually doing is studying the physical world. So all the things that you are studying exist in real world. For example, you study about heat, you study about oxygen, carbon dioxide. Yeah, you can't pretty much see them, but they are there. So that's science. But how about mathematics? All those numbers, equations that you study, they don't exist in real life at all. That you can't see them. There's no physical form of it, right? But then it's somehow very useful in our life. How is it, right? So here's one example. Numbers. You see 1, 2, 3, 4, and you can count until however large you want. They're pretty useless by themselves. We are the one that give meaning to them, right? You see, like for example, you want to count uh, how many sweets you have probably. So you have the same side of the same type of sweets, and you have probably 3 sweets, and your friend have 5 sweets. So now total you have 8 sweets. So suddenly it becomes a number problem all of a sudden. It's no longer about the sweet, right? So as long as it makes sense because it's the same type of sweet, you can do some arithmetic to it. And then you can come up with some number that represents the total number of the sweets. So same goes to every other mathematical concepts. So even for the functions or even for some of those ridiculous stuff that you study, they do have some sort of application in real life that you can give meaning to, but it depends on your field, depends on your domain and whatever you're doing, right? So like for example, the solving for the unknown variables may be used by accountants a lot to calculate debts and so this thing that you're doing, giving meaning to those abstract concepts of mathematics, is called a problem formulation. So that's a very important part. If you can't do formulations, it's pretty much useless whatever idea that you may have. So that's what's important about mathematics, and you should know about that, right? So now let's go to some example of machine learning, just to show you how those mathematics are being used in uh, machine learning, right? So in machine learning, data is very important, as some of you might already know. So what we always trying to do in machine learning is to draw some sort of conclusion from the data that we have, and use that conclusion to predict or forecast some kind of future event, or even to model the past events. So let's say, for example, that you have this company X. They are selling some product, and they are doing some advertisements. So this is the data about their advertisement and their total sales. So they notice that as they increase their budget for the advertisement, their sales also increase. Well, that makes sense, right? Because when you spend a lot of money for the advertisement, more people will be seeing your product, and therefore more people will buy your product. But company X wants to predict what will happen to their sale when they change their spending on the advertisement, whether they increase or decrease, right? So they want to know some sort of an estimation, more of a prediction of what will happen if they spend this much of amount of money on the advertisement. So they want to know what's the total sale. So using this estimation, they can properly budget their spending for the advertisements, right? So we have this data table here. So you can see when they spend 5,000, the total sale is 15,000, 9,000, 25,000, and so on. So the first thing that we should do here is to plot this in graph and see how the data points behave there. You see, when we plot each of them, x-axis is for the advertisement spending, and the y-axis is for the total sales that the company has done. So can you see some kind of pattern here? Like it's a straight line that going upwards. It might not be an exact straight line, because some of the data points are not really aligned properly, but it's close enough, right? What can we do with this data point? That's the question now. So now we go back to the functions that I first introduced earlier to you. You see, if we fit a function of f of x as written there, 2.35x minus 1000, we get that kind of line over there in the graph. It's not perfectly fitted into all those data points, but it's quite close enough, right? So this is how actually machine learning works in general. You have data point, and you try to fit a function to the data point so that it kind of models the variables that are included in the data set. So in this case, it's the total sales and the advertisement spending. You see, so now you can use this function to predict the future events, and you also now have the information of what's happening in between. So what happens if I have like 10,500 budget for the sales, for the advertisement? So that's how you get to the y-axis, which is the total sales. So this is what we call data modeling, right? From data modeling, you have this ability to predict and to forecast the future. So you see, the question now: how much sales would company X make if they spend 21,800 on advertising? I know it's kind of an odd number, right? But that's how the predictive power of machine learning is. You can just give whatever kind of number you want, and you can get the prediction quite accurately. So in other words, we already have the function earlier, right? The f of x 2.35 x times minus 1000. So all we need to do is to just plug in the value of x inside the f of x function. And now you see, when we plug in the 21,800, the value of it, what we get is actually 50,230. So you can see that when you model the data properly using these machine learning techniques, you can actually predict the future, something that never has happened before. That's quite cool, right? So that's the power of functions and how is it actually used in machine learning. So, of course, there is more towards this entire machine learning thing, and the example that I showed you is quite oversimplified. Um, but I'm not lying or anything regarding it. It's the truth. This is how the basic of the entire machine learning works. You feel the functions are the first step to the machine learning. So as you can see now, as you can probably see now, you can see how mathematics is being used in machine learning and it's how powerful it is. It's not all about just plugging in some library and calling the programming function there, right? So the example that I showed you is, of course, very simplistic kind of example. It's just a straight line. How about more complex data, right? So how about data sets like this? So you can see that you have some sort of curvy functions there, and I don't know what even is that. So you can see all kinds of data points that exist in real life, and in real life is often like that. It's not just a straight line or just a curvy line. It's often very noisy and very complex. So machine learning is able to model all those because machine learning is also sufficiently complex. So you can see, as you probably studied in your additional mathematics, the functions. There are more advanced functions there, right? The composite functions and stuff like that. So the composite function is actually one of the key factor that is needed in the mathematics of machine learning. So what kind of, now the question arises, what kind of data set that probably have this kind of functions that needs this kind of function to model them, right? Well, you can see probably like um, a housing price maybe. So the housing price over the years, and then the y-axis might be the price, and you can probably see a trend there, how it rises. So if you model the machine learning, if you feed a machine learning model, then you can actually predict what's the price of the house going to be in the next 5 years or 6 years. It's not going to be an 100% accurate prediction because, like I said, the real world data is often a bit noisy and complex. But they can give actually a very accurate estimation as it is now. So other stuff may be about predicting stock market price. So you can see, as you can see, probably this bottom right picture here, that looks more like a stock market trading graph. So there are machine learning models that can predict the stock market price, and actually there are people who are making money out of it. So they do some advanced ML models. They can predict the they can forecast the future stock market predictions, and they fit some kind of function there, and they can actually predict what's the price of a stock going to be given the time, and using that they can bid their they can put their bid, and they can earn money based on the bid if the machine learning model is sufficiently good enough. So not only that, the problem that I showed you here about this machine learning is called the regression problem, which means that you are trying to predict some kind of value uh, in the future or in the past, right? So there are also other machine learning problems such as classification. So you have like images of cats and dogs, and then you want to classify them, but it's still the same thing. The function is still there. You see, you have to feed a function there and try to find a boundary that separates the data points of cats and data points of dogs. So it's actually quite the same thing that's working on at the very basic level. So now that I think you might have some sort of idea of how important maths is inside machine learning, I can go on and introduce you on what kind of maths that you actually need to be good in machine learning. So you see, the most dominating topic of math in machine learning is actually called linear algebra. Don't be intimidated by all these names. They actually are from uh, they're actually the basics of all these mathematics are what you are studying in your high school right now, from one to form five. So linear algebra is mainly built on the algebra, which is the the calculation of the unknown variables. It's just a bit more complex than that, but given that's the basic of it. And probability theory and statistics, you probably will study that in Form 5. Calculus, also Form 5. Algorithm and complexity, you'll study in computer science. And inside others, you have other mathematics such as geometry. You need to calculate the trigonometry stuff and stuff like that, and maybe some dynamical systems and things like that. But it's good enough as a computer scientist for you to know about linear algebra, calculus, and probability, and of course the algorithms and complexity. Well, is it too hard? Well, that's the thing. There are a lot of people that have asked me this before, that mathematics is taking too much of time for them to learn. Why not just plug in some library and get your machine learning model done, right? I mean, you actually don't need to know maths to program all these this machine learning models. You can just call some library, plug it in inside the data set, and get on with it. You can get some prediction. But that's the thing, though. You plugging in those libraries is just a convention. It's not something for you to do as a full-time machine learning engineer or a researcher, or if you are serious about machine learning at all. Because the reason is those functionalities given by the libraries are limited. So if the libraries does not have the function that you require to solve some sort of problem for your company or for yourself, you're not going to be able to do it because you don't have the mathematics knowledge to understand what's going on inside the libraries, right? And you will hit the ceiling very quickly. You can do stuff, yes, and people will say that you are good and what's not, but uh, you can only go so far. You can't go after a certain limit. Um, Another benefit of knowing this mathematics is that you see, when you learn mathematics in a very systematic manner, in a very thorough fashion, without skipping the reasonings and deductions of all those theorems that you might encounter. I know you probably haven't heard of any kind of theorems in your mathematics right now. The maths that you are studying in your schools right now are super basic stuff, and they are not even the full capability of mathematics. When you actually go to universities and read more books by famous authors, then you will encounter theorems and stuff like that. So you see, theorems are just some sort of a mathematical construct that will introduce you to formulas and facts in the mathematics that you're studying right now. So when you study them with the proper reasonings and deductions skills, it can actually make you sharper and smarter. Your whole thinking style will change to be better. You can ask better questions, and you can obviously do a lot of things. So you can actually solve new problems without any reference or help. I mean, that's a given because you know things very deeply. And here's the most important part: when things go wrong, and they will, trust me, in machine learning, you can identify and fix it effectively if you have the sufficient mathematical background. If you don't have the mathematical background that are needed, you're gonna not know what went wrong and how to even fix it, how where to start in the first place, because you're so dependent on those libraries, right? And remember the potato chips that I presented earlier? Yeah. So you can also build more quality products. People will trust you more, and of course, your company will pay you more. If that's not enough reason for you to learn maths, then I don't know what is. So these are some of the reasons why you should not skip maths. And so now, if you have some questions on where to start with all this mathematical thing, I would suggest you to focus on all the mathematics subjects that you're taking in your school right now, whether you're taking additional mathematics or not, or whether you're just in Form 1 to Form 3 where you are taking the basic mathematics. You should go through with it, get it done, be good at it. If you're taking additional mathematics, consider yourself lucky, because most of the content from the additional mathematics will be used in machine learning. And once you are quite satisfied with your knowledge, if you think that you have done enough for your mathematics in your high school and you want to go further, you can start with this book called Linear Algebra with Applications by George Nakos. It's a very good book, and it's one of the most important topic for machine learning. So I would suggest you start with that, but it should be a bit more than what you should be able to handle. So remember that if you can't really follow through the book, don't push yourself too hard. You can always try to skip some and get the big picture, and then come back and read the book again for the second time when you have the enough hindsight and also have enough knowledge in your university time. So you can try read it to at least get some sort of an idea. But remember again, do not push yourself. So let me recommend you some other stuff that you can use for uh, that can give you some sort of insight and more some sort of preparation for your learning journey in machine learning, right? So if some people might have more interest in calculus than linear algebra. Both of these are needed for machine learning, and you can actually start with either calculus or linear algebra. It doesn't matter, but it is recommended that you start with linear algebra first because it's often easier than calculus. So there's a very good book of calculus that I read. It's by Stewart. It's called The Calculus Early Transcendental. He had many books, but you can choose this book if you want. Early Transcendentals, 8th edition. So in the book, they will give you step-by-step examples of how things are applied in real life, and also the concepts of those calculus. They will start with functions, of course, functions, differentiations, and so on. But here's the thing: for machine learning, you don't have to finish the entire book. The book is quite thick, to be honest. It's about 2,000 pages, so you don't have to finish the entire book to be good in machine learning. In fact, you only have to be good about up until probably chapter 6 or 7, because that's basic. A lot of even until advanced machine learning models are using only until that kind of calculus. For linear algebra, yes, you have to finish the entire book. So apart from that, I also have some more recommendations for you. There's a masterclass by Neil deGrasse Tyson. He will teach you how to think and communicate scientifically. It's not fully mathematical. There are some sort of mathematical elements in there, but it's more towards your thinking skill. So I would recommend you to watch that. And also, finally, Andrew Ng's ML course in Coursera. It's free. That's the fun part of it. It's kind of hard to follow through, but you can try this ML course in Coursera. And yep, that's about it. Thank you very much for listening to my talk. Let me know if there's any questions or comments that you have.
There's a question here from.
Okay, this.
Is there any way to find best fit graph?
Yep, good question. So here's the thing. What I showed you earlier was right. So what I showed you earlier is a function that's fitting these lines, these dots, right? So machine learning works like this. When you have all this data, it doesn't know how to fit the function straight away onto the data points, right? So what it does is actually randomly fit a fit a line in the graph, and it calculates how far is it off from each of those data points. So it calculates the distance. So this is where your Pythagoras theorem might be useful. So it calculates the distance from each data points, and then it tries to reduce those distance from the data points to find the best fit. So that's how it does it. So that's where the training occurs actually. So in every iteration, the training reduces a bit by bit. So here is where calculus is needed, the differentiation. You need to calculate how far it is from, and how do you need to adjust your function's parameter. So in our case, the function parameter is those 2.35 and the 1000, right? So it will try to adjust it slowly until it comes to a point where it cannot fit anymore, or until you stop the training. So that's how you finally find the best fit to the graph. So is that answer satisfactory? Is there any other questions?
By now, no. No more questions from others.
Okay.
All right. Thank you very much for your speech.
Thank you for having me here. Yeah.
Right. Thank you.
All right. Goodbye.
Goodbye.